Hello everyone. In today's lecture, we go with the new concept of the chapter trigonometric functions, and our concept is here we have to define the polar coordinates. And to define this, we consider one fixed point. Let us consider here O is our fixed point. Then we consider one fixed array. Here OX be the fixed array. Okay, here OX is the fixed array. I repeat again, here O is the fixed point and OX is the fixed array. Here this point O is called pole. Here this point O is called the pole, and this array OX is called the polar axis. Now by using this polar axis, we have to define the polar coordinate. Let us consider any one point in the plane. Let P be the any point in the plane. Let's join this OP. Okay, here we consider the angle in between the array OX and this OP is theta. Okay, so this is the angle theta, and this is called the vectorial angle. Here theta is the vectorial angle. Then here we consider OP, that is length of OP is R. Here length of OP is R. Then here the order pair are theta. Here this R is called radius vector and theta is the vectorial angle, and the order pair of the radius vector and the vectorial angle is called the polar coordinate. Okay, so here point P is for the polar coordinate, and here coordinates are here P of R theta. So remember this point here P of R theta. Okay, then here this theta is the non-negative angle. And this theta always lies in between. Here 0 is less than equal to theta and is strictly less than here 2 pi. Okay, so theta always lies in between in these two, here 0 and 2 pi. Remember here this point O is called pole, and the pole has no polar coordinates. This pole has no polar coordinates. Remember this. So by using this concept, we define here polar coordinates. Okay, now we consider the relation in between the polar coordinates and the Cartesian coordinates. Okay, so here I write relation between the Cartesian coordinates and the polar coordinates. Okay, so here we consider Cartesian coordinates. Let P of xy is related with, or this xy, order pair xy is related with the Cartesian coordinate, and we consider this r theta, and this is related with the polar coordinates. Now to define the relation, we consider one figure. Let us consider the coordinate axis. Okay, this is our x-axis. This is negative side of x-axis, that is x dash. Then we consider here y. This is our y-axis, and here this is a negative side of y-axis. So we consider this coordinate axis. Then we consider any point in the axis. Let P of xy be the given point. Let's join here this O. This is our O. This is our pole. Okay, so we join here OP. Here length of OP is R. We consider this length is R. Then we consider angle in between here OX and this OP, that is we consider the vectorial angle. Here vectorial angle is theta. Vectorial angle is theta. Now to define the relation, we consider here one perpendicular drawn from this point P to the x-axis. So here from point P we draw the perpendicular like this. Okay, so here perpendicular is at M, is on x-axis. Okay, so by using this concept we have to define the relation. Now everyone knows the trigonometric functions. We know sine theta, we know how to define the sine theta, we know how to define the cos theta. Okay, so we go with our definitions of the trigonometric functions. Here we know sine theta is equal to. Now everyone remember, this is the right angle triangle. Here one side having length, that is here OM is having length x, then here PM is having length y, okay, and here hypotenuse is OP, and we denote this by using this R. So here we know sine theta for the given angle theta. Here for sine theta we know opposite side upon hypotenuse. Here opposite side is PM, and we know here length of this PM is y. So y divided by hypotenuse is OP, and for OP we consider R. Similarly, here for cos theta we consider adjacent side. Here adjacent side is OM having here x. So here x upon, then hypotenuse is OP, and we know this is R. So here we get sine theta is y upon R, and this cos theta is x upon R. Here I write this y separately as here R sine theta, and here I write this x separately as R cos theta. X is R cos theta. So we get here P of xy and is equivalent to here P of here R cos theta, then R sine theta. Okay, and this is the relation in between the Cartesian coordinate and the polar coordinate. So everyone remember, here x is equal to R cos theta and y is equal to R sine theta. So in today's lecture we go with some important examples related with this concept. Okay, so here we go with our concept. Example here given, find the Cartesian coordinates. Find the Cartesian coordinates of the point whose polar coordinates are here in first given root 2 pi by 4. Okay, now here polar coordinate are given, we have to find the Cartesian coordinate. Let us consider given point again. We know here polar coordinates are r theta is the order pair having the radius vector and the vectorial angle, that is r theta, and is equivalent to here root 2 and pi by 4. That is here r is root 2 and here theta is pi by 4. We have to find the Cartesian coordinate, that is P of xy. Okay, and we know how to find x and y. We know to find x we consider r cos theta. Okay, this is equal to, we know r is here root 2, then here cos of, we know theta is pi by 4. We know cos pi by 4 is 1 upon root 2. So root 2 into 1 upon root 2. And we know this is 1. So we get x as 1. Similarly, we find y. Similarly, here we find y by using r sine theta. This is equal to, we know r is root 2 into sine theta. Here theta is pi by 4. Now, this is equal to, here root 2 into, we know sine pi by 4 is 1 upon root 2, and we know root 2 upon root 2 is 1. Root 2 upon root 2 is 1. So, we get x and y. So, I write, therefore, the required Cartesian coordinates are here order pair 1 1. Is having order pair 1 1. So we find the Cartesian coordinates by using the polar coordinate. Let's go with second example. Here in second, given 4 pi by 2 is the order pair having 4 and pi by 2. Let's define here order pair r theta is equivalent to here 4 pi by 2. Remember, here r is the radius vector and theta is the vectorial angle. And by using this, we know how to find x and y. That is how to find the p of xy. Okay. So, here we know x is r cos theta. Here r is 4. So, 4 into cos pi by 2 is equal to here 4 into, we know cos pi by 2 is 0 and 4 into 0 is 0. Similarly, we find y by using r sine theta. Okay, again we know r is 4 into sine pi by 2 is equal to here 4 into, we know sine pi by 2 is 1 and here 4 into 1 is 4. So we get x and y. Therefore, the required Cartesian coordinates are here having 0 and 4. So we find the Cartesian coordinates by using the polar coordinates. Let us see one more example. Here in third, we consider 3 by 4, 3 pi by 4. 3 by 4 and 3 pi by 4. Let here r theta, this order pair r theta is having or is equal to here 3 by 4 and 3 pi by 4. Let's find x first, and for this we know here x is equal to r cos theta. We know here r is equal to, here r is 3 by 4 into cos of theta is 3 pi by 4. Now by using allied angle form, we have to find cos 3 pi by 4. Okay, so here I write x is equal to 3 by 4. Now we know here cos of 3 pi by 4, here cos of 3 pi by 4 is here cos of pi plus here pi by 2, here pi by 2 plus pi by 4, pi by 2 plus pi by 4. Okay, so here we know if we calculate this, here we get 3 pi by 4 is equal to here 3 by 4 into here cos of. Now everyone knows this pi by 2 plus pi by 4 is in the form pi by 2 plus theta. We know this pi by 2 plus theta is in second quadrant. In second quadrant, this cos is always negative. This cos is always negative. Then here if pi by 2 is given in the allied angle, then we replace this cos by using sine. So here sine of pi by 4. Now this is equal to here minus 3 by 4 into here we know sine pi by 4 is 1 upon root 2. And lastly, we get minus 3 upon here 4 root 2. This is our x. Similarly, we find y. Okay. So here y is equal to we know r sine theta. This is equal to we know r is 3 by 4 into sine of here 3 pi by 4. Again, by using allied angle formula, I write this sine 3 pi by 4 as here sine of pi by 2 plus pi by 4. Now, this is equal to here 3 by 4 into, again, we know this pi by 2 plus pi by 4 is in the form pi by 2 plus theta. Here pi by 2 plus theta is in second quadrant. Okay, and in second quadrant this sign is always positive. Sign is always positive. Here given pi by 2, so we replace this sign by using cos. So cos of pi by 4 is equal to here 3 by 4 into here cos pi by 4 is 1 upon root 2, and lastly we get here 3 upon 4 root 2. Okay, and in last here I write this as, or I write the Cartesian coordinates. Therefore the required Cartesian coordinates are here having minus 3 upon 4 root 2 and 3 upon 4 root 2. So we find the Cartesian coordinates by using the polar coordinates. So remember this example. Let's go with another example. In that we have to find the polar coordinates, and for these Cartesian coordinates are given. Okay, so here find the polar coordinates of the point whose Cartesian coordinates are okay. So here in first given root 2 root 2. Okay, this Cartesian coordinate is given. Let us consider this as xy. Okay, let here xy, order pair xy is equivalent to here or in order pair root 2 root 2. We know this point is in first quadrant. This is in first quadrant. Okay, now here to find the polar coordinates, we consider r theta, that is a radius vector and the vectorial angle. And to find this radius vector, that is r, here we consider r is equal to square root of x square plus y square is equal to, here we know x is root 2, so root 2 square is 2 plus, then here y is root 2, again root 2 square is 2 and is equal to root 4, and we know root 4 is 2. So this is our r. Now in next we have to find the vectorial angle, that is theta. Okay, since our point is in first quadrant, if this is in first quadrant, we find theta by using here tan inverse of y by x is equal to here tan inverse of, we know y is root 2, we know x is root 2, so this is equal to here tan inverse of 1. Okay, and we know tan inverse of 1 is here pi by 4, is pi by 4. Okay, so here we get the polar coordinates Therefore, the required polar coordinates are here having 2 and pi by 4. Okay, so by using the Cartesian coordinates, we find the polar coordinate. Let us see one more example. Okay, here in second, given point is having 1 minus root 3. Okay, so here this xy is equivalent to 1 minus root 3. Let's find r first to define the radius vector. Here for r we consider square root of x square plus y square. Okay, so here square root of, we know x is 1, so 1 square is 1. We know here y is minus root 3, so y square is 3, and we get root 4, and we know root 4 is 2. Now we have to find the theta. That is vectorial angle. Okay, so here we know this point 1 minus square root of root 3 is in fourth quadrant. And in fourth, if this point lies in fourth quadrant, we find theta by using here 2 pi plus here tan inverse of y by x. Okay, here 2 pi plus tan inverse of, we know y is here minus root 3 upon x is 1 is equal to here 2 pi plus tan inverse of minus root 3. Okay, this is equal to here 2 pi minus, okay, here tan inverse of minus root 3 is given, and this tan inverse of minus root 3 is minus tan inverse of root 3. Okay, now this is equal to, this theta is equal to here 2 pi minus, now here tan inverse of root 3 is here pi by 3, so this is equal to, we know this is 6 pi minus pi upon 3, and lastly we get here 5 pi by 3, so we get the theta. Therefore, the required polar coordinates are here r is 2 and theta is 5 pi by 3. So by using the Cartesian coordinates, we find the polar coordinates. So in today's lecture, we see the concept of polar coordinates. We define the polar coordinates. Then we see how to find the polar coordinates by using the Cartesian coordinates. Then how to find the Cartesian coordinates by using the polar coordinates. Thank you.